The little picture is from a nanofabrication study, which shows you can make very high quality, and do this in just a jet in a very simple way, make high quality alumina particles just by spraying aluminum vapor out, which oxidizes. So it's certainly in principle possible to do that, and there's a big literature that's already looked at that. And you could do that by either building new versions of these aircraft or even re-engineering existing aircraft. So there's some ideas of that. So you go to an engineering firm and you want this done. They don't say this is hard or unusual. They say, okay, yes, we could do it. Aerosol geoengineering looks like it is so cheap that the cost is basically not going to be an issue. That means that implementation decisions will be risk-to-risk decisions. The risk of doing it against the risk of not doing it. And it makes the problem of how we govern it fundamentally harder and different and novel. So I've told you that it's cheap to deliver materials to the stratosphere, and I'm convinced that's true. I don't think that will change. But I think the more we do research, the less easy this will look, the more complicated the environmental effects will look. And that's a good thing, because right now it looks too easy. So I think that if we do more research, we're likely to find out that it's harder and more complicated than we thought, and that the side effects are harder to manage, and that's a healthy outcome that will make it easier to do the management. Of course, the opposite reaction is possible. It's an empirical question, how people will actually react to knowledge about this. Another reaction is to say, if these crazy scientists are so concerned about putting CO2 in the atmosphere, they want to think about these things, then that might actually mean we should be more serious about the risks of CO2 in the atmosphere. And by the way, it's not really a moral hazard, it's more like free riding on our grandkids. And by the way, it's not really a moral hazard, it's more like free riding on our grandkids.
Numerous air quality studies, including from CARB, California Air Quality Resource Board, have named submicron-sized particulates as being particularly harmful for human respiration. Through all the discussions today, I have not heard any mention of this fallout, and has this been studied, and also the effects of a highly reactive metal like aluminum on toxifying soils and waters?
The question is, what would be the effects of these materials on human health if they came down into the stratosphere, in particular small particles in aluminum?
So the collaborators of mine working on the aerosol scheme are actually folks from Carnegie Mellon who focused on human health impacts. And while we haven't published it, that was the very first thing we did, was do the order of magnitude calculation in bevel pencil and paper, but with an expert on human health impacts about whether there could be an issue. And for aluminum or other particles, there are a lot of toxicological things that need to get looked at seriously. But if you're just thinking about the sheer number of particles and the human health impact of small particles, the answer is, well, we haven't published it. That was the first thing we looked at with some of the leading experts who do epidemiological research on human health impacts, and it's not even close to being an issue.
Clarify, so 10 megatons of aluminum dumped into the atmosphere would have no human health impact.
So let me be more careful here. We're to separate out the toxicological. So the alumina, we've only begun to research and published nothing. The alumina, we've only begun to research and published nothing.
Dane looked at him and he said, so you're telling me that spraying 10 to 20 megatons of aluminum, as you said, would have no human health effects? He took a deep breath and he swallowed and he said, let me be more careful here.
We haven't done anything serious on alumina, and so there could be something terrible that we'll find tomorrow. We haven't looked at it.
And that, for me, that was the whole main point of what is going to be coming out to the public. It's the damaging effects of aluminum that are being found around the world in massive amounts. Here's David Keith confronted on this very issue, and he looked, you know, at that point like they just let the cat out of the bag.
Mm-hmm. We haven't done anything serious on alumina, and so there could be something terrible that we'll find tomorrow. We haven't looked at it.
They're proceeding because they have an agenda that's separate from trying to thwart this crisis of global warming. You know, there's obviously several other objectives, whether it's depopulation, control, weapons aspects, communications aspects, all kinds of things, you know, wild cards that we know nothing about. We don't really know, and I'm not going to attempt to speculate on exactly what the agendas are, but we can see clearly the agendas are not benefiting mankind. You know, it's benefiting the agenda of the elite.
Io mi chiamo Giorgio Pattera, sono di Parma, sono laureato in scienze biologiche, sono giornalista pubblicista e mi sono interessato al problema chemtrails o scie chimiche che dir si voglia per caso, in quanto un carissimo amico e collega per altre motivazioni mi ha chiesto nell'ormai lontano dicembre del 2005 se accettavo di analizzare l'acqua piovana caduta in provincia di Milano che lui sospettava contenere delle sostanze che non dovevano esserci. Le abbiamo analizzate e abbiamo trovato quello che non solo non mi aspettavo e non ci aspettavamo di trovare, ma quello che non ci dovrebbe essere, e cioè una serie di elementi chimici sotto forma cristallina che nell'ambiente e soprattutto con le precipitazioni non dovrebbero assolutamente essere passibili di essere inalati o comunque ingeriti una volta che l'acqua piovana contamina le coltivazioni di vegetali o quant'altro dall'uomo, perché sono potenzialmente pericolose. Con questo nessun tipo di allarmismo o di catastrofismo, però quando si trova un 83% di quarzo in queste precipitazioni io ritengo che non sia assolutamente accettabile una cosa del genere. Una volta appurato quello che c'era in queste acque piovane, io mi sono ricordato che molti anni prima mi erano arrivati un po' da tutta Italia dei campioni, sempre da analizzare, non di acqua piovana, ma di filamenti strani. Nell'ottobre 2001 un testimone oculare che raccolse questi polimeri in seguito al passaggio di uno stormo di aerei non identificati sul cielo di Roma mi mandò questi campioni che io analizzai e riuscì solamente a determinare la natura di questi filamenti come polimeri di probabile origine organica, non biologica, ma organica e per di più sintetica. Faccio una distinzione. Quello che è organico non è detto che sia biologico e viceversa, ma può essere anche sintetico. Mi spiego meglio. Il petrolio, ad esempio, è di origine organica perché sappiamo tutti come si è formato, ma non è biologico perché oggi nessun essere vivente, vegetale o animale, possiede il petrolio nella propria costituzione. Molti polimeri invece, pur essendo derivati organici, sono di sintesi, cioè l'uomo li ha fabbricati in laboratorio. La cosa si è ripetuta sia per i filamenti caduti ad Alessandria nel 2002, per gli stessi filamenti caduti ad Argenta a Ferrara nel 2003, per Mondovì nel 2007 e finalmente, come dicevo prima, nel nord Italia, tre quarti del nord Italia, tra il 5 e il 9 novembre del 2008, tra cui a Parma.